Hello, everyone, and thank you for joining me for today's episode in Caserta's Data Intelligence webinar series. I'm your host, Remy Rosenbaum. Today, we're going to explore how to use DevOps to bulletproof your data strategy. The modern successful organization has many different technology work streams in play, such as data creation from users, both back office and customers, marketing campaigns, applications, and more. And the tools we have to curate and manage all this data have advanced a lot in the last decade. However, the processes have not. And while reports may come faster, the ability to integrate them with our business tools and applications continues to be burdensome. In this episode, we have two excellent speakers that are going to address this topic. First, we have Caserta's founding president and data thought leader, Joe Caserta. Joe is an internationally recognized public speaker, entrepreneur, and technologist. Joe is the co-author of the Data Warehouse ETL Toolkit, an industry best-selling book that has become the gold standard for preparing data for analytics. Joe is recognized as an authority on enterprise data analytics and continues to innovate and expand his role in the industry. After Joe, we'll have Chris Mathias present. Chris is an authority on DevOps, data strategy, API development, designing and developing APIs, and authoring and presenting them for Fortune 500 companies as well as startups. As Director of Architecture at Caserta, Chris is also responsible for designing analytics systems from the ground up. Caserta's complimentary data analytics expert webinar series is designed to give you insight into today's hottest technological trends and issues. And after today's webinar, I encourage you to speak with us about any questions you have on how to apply what you've learned today at your organization. Our initial consultations are always free, and if we find an opportunity to work together, then we can discuss the next steps. And if not, we'll gladly point you in the right direction. After the webinar, I'll send you a recording to the email address you provided. If you have any questions throughout the presentation, please enter them in the questions panel on the right, and we'll answer them during the live Q&A session at the end of the webinar. Joe, the stage is all yours.
Thanks, Remy. Great intro. Appreciate it.
Thank you.
So just want to talk to you a little bit about. I'm going to spend 30 seconds on Caserta and then dive right into it. I do want to tell you why I think we're qualified to give this webinar. So we have 18 years of experience building solutions for data, and we'll talk about like why data and DevOps have converged recently. And a lot of what we're going to talk about is best practices that I wrote in a book 15 years ago, and also best practices that Doug Laney has written in Infonomics, which is another bestseller. Doug Laney recently left Gartner and now is a thought leader within Caserta, and we're very excited to have him join us. As a company, we cover big data, analytics, architecture, visualization. Our core competency has been for years and years, for decades actually, building data warehouses, business intelligence tools, and enterprise data management systems. And we are partnered with all four of the major cloud providers: Amazon, Google, Microsoft, IBM. To do cloud migrations and cloud re-engineering. We are very excited to say that we are growing at incredible leaps and bounds, and we are hiring. If you're a data engineer, DevOps engineer, data architect, data strategist, or even sales, marketing, administration, we're hiring across the board. We have about 17 open positions at the moment. So feel free to reach out to any one of the three of us after this if you're interested in coming to work for Caserta. So why does a data warehouse, data analytics company care about DevOps? It seems like DevOps really is for application development, which is a different world, right? So when you have applications, right, you need to have a very iterative approach where you can have continuous deployment, continuous integration, and constantly adding new features. With data warehouses, it tends to be a little bit more waterfallish, right? You have your ETL processes, your data models, your reports, and it's very much a downstream process from your core applications. That used to be the case, and for the past 2 decades, that's what we've been doing up until around, I'd say, 2011, 2014, when the world started changing, when big data started to be relevant in 2009, we were treating it a lot like a data warehouse, right? We were building a Hadoop platform, and we were still doing things very much downstream. And then it got really interesting. Then we started getting data from other sources, and integrating it and taking the data from the applications, enriching it, and then doing really interesting things like not just analytics per se, but more machine learning, artificial intelligence, really taking the data and having the machines apply intelligence and get insight without the need for having a reporting system or humans involved with reading reports. So once that happened, right, two things happened. One is we started doing analytics on the analytics platform itself. But the other thing on this slide that you'll see is this little blue diagonal line, this multi-directional line. This multi-directional line really changed the world of data as we knew it. What this means is no longer is the analytics platform downstream from your business applications. What this means is now your data and your insight and your application are all tightly coupled. So now our business applications actually depends on analytics to function. Things like rendering, what to show on a screen in real time based on the user, based on the user's prior behavior, based on the user's peers' prior behavior, based on the products or services on the screen at that moment, based on what's in the shopping cart at that moment, based on what's been browsed lately, based on what we just want to show from popularity and for sales initiatives and campaigns, right? All of those things considered feeding models in real time to get insight and are affecting how the applications actually render and how we can influence the user in real time using machine learning and artificial intelligence. And that is a game changer for the data world. No longer can we have a separate SLA for a service level agreement for a data warehouse different from your business applications. Now we have to have business applications and analytics insights functioning together, right? So the way we do that is through microservices, APIs, and DevOps. And Chris will talk into the details, but I want to get into just a little bit of the paradigm shift of where we were and where we are. So we used to, build structures, load those structures with ETL processes, and then analyze those structures, very monolithic, very waterfall. Now what we're doing is we're really just ingesting data, disseminating data, getting insight in real time. And then if we need to apply structure to do some reporting, we can do that, but it's no longer an absolute requirement. So what's changed is rather than having just a data warehouse or a business application, everything works holistically as an ecosystem. So a data ecosystem now replaces, the disparate, isolated applications that we used to have yesteryear. The other thing that changes is rather than having waterfall project management, we now have an agile DevOps environment that spans both the business applications development and the analytics platform development. The recipe for that is generally we're moving to the cloud, don't have to, but 99.9%, actually it is about 92% of our clients right now are on the cloud. Usually we typically need a data lake because we're not going through the rigor of building a formal, fully structured data warehouse anymore. And the other key recipe is to have an API layer, an API gateway, and API management. And Chris will dig into that a little bit more. So this is a standard practice for whenever we build a data analytics platform. We use our methods that we came up with called the corporate data pyramid. The corporate data pyramid has a few tiers of data ingestion, a data lake, ephemeral data workspaces or data science laboratories, and then ultimately a data warehouse for fully governed queries. What's changed is instead of having it all go through these processes with different ways of entering and getting your data, we are now provisioning all of our data assets through a service, through an API gateway. So data as a service is really becoming the go-to method on how to build a data ecosystem for an enterprise. So in order to have data as a service, you have to have an API gateway. So all of your provisioning, all of your security, all of your data preparation, aggregation, everything that you need to interact with your data, either to put data in or to get data out, should be through an API gateway. There's many components within the API layer, which Chris will get into, but holistically, this is essentially what it looks like. So when we have different methods of doing things, typically means you need to have different people, or at least people changing and enhancing their own skill sets. So data engineers are, something that we've had for at least a decade plus. Data scientists also, but what's new is now we have to have on every data project, we have cloud engineers and DevOps engineers. And it is a different skill set from a typical data engineer and a typical data scientist. No understanding, what a DevOps engineer does is critical to every application. And their key responsibility is to be able to operationalize the analytics integration. So what that means is, so we have data engineers building pipelines, we have data scientists building models, but we need a DevOps engineer that can make everything talk to each other and also interact with other applications outside of the analytics platform. So part of our service is to figure out where our clients are in the analytics maturity, and the goal should be, to be on a scale of 1 to 5, we want to be able to get you easily past reporting and correlations and even predictive models, to the point where like 4 or 5 is where now we're building recommendation engines. We're building an API layer on top of it, and we'll be able to do artificial intelligence. And the only way to do those two things at the end, especially AI, is to be able to have an open system where you can easily interact and between your application that the user experiences and the insight that comes out of your analytics platform, and be able to do that in real time. And so now Chris is going to explain to you not why we're doing it, right, but how you do it, and take it away, Chris.
Thank you, Joe, for the excellent presentation. Now we're going to move on to Caserta's Director of Architecture, Chris Mathias. And Chris, take it away.
All right. Thank you, Remy. Thank you, Joe. That was a great, insightful, informative, big picture perspective there. I'll try and just add a little color to all the good stuff you brought up. So we're going to cover a lot of the similar details, but with a little more to it. So we're going to go over a little bit on data ecosystems. We're going to talk about what is work, what is flow, and how does that apply to how information and process gets applied in your organization. What's the value of isolation in the context of work and flow and in data management? DevOps and a newer term in the industry, data ops, and then how we can find value in this overall process cycle through feedback loops. So a data ecosystem is not a very clearly defined thing. In fact, there's some academic papers out there trying to put some rails around this and have a reasonable definition. So my wide swath definition is all those many things that touch your data. So you can imagine in your organization, I'm sure you have a wide variety of inputs and outputs and connectors to try and make things all talk to each other. We worked at one organization, for example, where they acquired 3 different organizations in an attempt to build an e-commerce platform. And one application they brought in was in .NET, and another was in Java, and a third was in Perl. And they wanted to be able to bring all 3 of these together. So there's a whole API architecture component of making everything talk to each other. But then one of the end state goals was to be able, within the application, to provide back to their customers a clear, concise, consolidated report of what their sales were, what their leads looked like. So it's not just the accounting side, but also the marketing side and point of sale details. And so there's so many moving parts in bringing all these pieces together and then synthesizing them into an analytics report, and then making that analytics report pretty reactive so that they can get reports outside of just end of month, end of quarter type reporting. So this is a definition that I like around data ecosystems. And in fact, there is no one data ecosystem solution. Every business really winds up creating its own as an artifact of the different requirements of the components and technology choices that they've made. So they come up with this technology stack, and it's really just often a patchwork of hardware and software that collects, stores, analyzes, and acts upon the data. So if these are the dots that we have in the system, we've got how do we get the data, where do we store it, how do we analyze it, how do we act upon it, how can we connect all these together? And a lot of times, even within the example I gave earlier, that was 3 different acquisitions being brought into an organization, but it's often even bigger than that, right? So many times we're trying to alleviate some of the burden of data collection ourselves, and so we wind up picking up vendors and broadcasting data out to different vendors, and then trying to circle back with those vendors and pull their vision of the data back in. Examples include Mixpanel was one of them, or situations where maybe you've got a mobile app and you're broadcasting data out to Appsy or another type of mobile integration vendor. You've got data from the App Store, you've got data from your marketing campaigns, and so you end up with your data that you technically own, so to speak, in 3, 6, 8, 10 different systems, and those systems tend to have APIs, and there's some API aggregation vendors that can help out, like Treasure Data or Segment.io, that have pre-built integrations to all these different concerns, and you can round up all that data through their systems, and they'll homogenize it for you, and that can be helpful, but it still only gets you halfway there. You've managed now collection and maybe a little bit of storage, but then you still end up wanting to analyze that data either in their system, which you're stuck with their tools, or you want to bring that into your system and be able to impose your own tools upon them, and then ultimately gain some learnings from that analysis and surface those learnings back to the business, back to your product. So that giant mess of systems winds up a lot like you can see here a picture of a guy underneath a set of racks. So I've done some time in colo facilities and played this game of being on the phone and connect the wire. And this is probably still a reality in a lot of places, but it's also just a representation of the type of systems, scattered systems and integration that we often end up with in organizations where how this information ultimately needs to tie together, be used, and be reported back to the business is maybe not as clearly defined as in other areas. So some of the tools in software engineering that we've come up with over time to try and manage this type of complexity, things like you've heard the term microservices, continuous delivery, the tools to facilitate these things. There's Jenkins, code pipelines. These are different systems that have been put together, tools that have been put together to facilitate how to ease how information goes from point A to point B, whether that's a developer writing code to go to development, or that code going into production, whatever the process flow is. It's not just the individual deployable components that have been segmented and simplified, it's also the tools that deploy those components across your system. And we'll get more into that in just a moment. So I want to talk for just a minute about work and flow. So when we decide to do a thing, it's never as easy as we once believed. So we think, well, I want to create, this thing, and when I'm done creating this thing, I'm going to put it over here, and I'm going to be done. And so, we tend to talk in terms like this, where things sort of seem easier until we get down into the details. And without one, appropriate planning, but also two, appropriate rails around the processes that we undertake to manage this work, things kind of go sideways. So in a perfect world, and of course, what our CEO or CIO always thinks, we're going to have an idea, we're going to do some stuff, it's going to cost a little bit of money, and we're going to get some value out of that work. But inevitably, we get into the weeds, and this is the sort of thing that occurs. So the amount of time it takes to accomplish something somehow always grows outside of what we ever expected it possibly could. And while this problem has been addressed quite heavily in the past few years in the application development space, it's been not as highly addressed, I think, in the data space. And so what we're trying to do is, in the data space, be more progressive about how we approach the units of work that we're taking on, and how to apply some of these great ideas that have come up in the application development space and apply those to data management and the like. So if we tighten down and restructure our processes and our goals, then we can get to a pretty tight feedback loop that can enable the manifestation of value from the idea and the work performed back to the business. And we can cut our cycle times down to hours or days or even weeks, but much shorter than weeks, months, and years, which is often the case in these types of projects. Now, feedback is one of the missing elements in here. Obviously, there's a lot of others that have to do with process and flow, but one of the things that happens in these projects sometimes is we tend to think of things if I have to solve the entire data warehouse design and ETL process before I can get any feedback. And I just don't think that's necessarily true. We want to try shrinking the unit of work so that we can produce more work more rapidly, and we can have more rapid iterations of feedback with our stakeholders, whether they're our architect or our product owner or our CIO. The ability to surface results more quickly and get feedback more quickly will inevitably produce a much better flow of value for work performed in your organization, which is what we've learned on the IT DevOps side in application development. So there's value in isolation of these concrete chunks of work. So in the old mindset, people would think things like deploying is the most expensive, risk-fraught, time-intensive activity we can engage in. How is it possible that more frequent deployments can do anything but create longer timelines and more risk? And this is where I was at too, 4 or 5 years ago, when some of these ideas were brought up, and it was really the microservice changeover that occurred that I had jumped onto. That at first it just seemed implausible that these things could actually facilitate. And then in doing so for a little bit, it takes just a little bit of active practice in these strategies in order to apply the learnings and really see how the benefits can take place. And so this is one quote that I captured around having actually practiced these things. Forcing ourselves to deploy more frequently has required us to make smaller changes and add much more automation in testing, deployment, and security, which reduces time to market. And it's time to market not just outbound, to your customer necessarily, but just to whoever your customer is internally, even being able to get that feedback more rapidly. So I won't read the whole quote here, but the Unix philosophy: do one thing and do it well. I like to apply that same perspective in the context of any of these active development exercises. So we can adapt this principle. We can make many small changes frequently and iteratively, and releasing when appropriate. These changes are tested thoroughly with automation and release with automation. And by adopting these values, these aspects of our processes, we can decrease what we call cycle time. So cycle time is that idea you just think about how long does it take between when I've decided exactly what I'm going to do to it being manifest in front of my customer, again, being your internal customer or your external customer. The isolation of changes allows these changes to go a lot faster through the system. So by decreasing the cycle time, that's manifest more quickly. Every increase in functionality leads to an increase in cycle time. Now, traditionally, we've known this as scope creep, for instance. It's a very common phrase in application development. And what happens is traditional waterfall or agile, we package up this group of functions and we say, well, all these have to go together or none of them go. And one of the things that this process methodology asks is that necessarily true? There's a difference between goes in front of my internal customer and goes in front of my outward facing customer. And a lot of times we find that leave off the final endpoint. Let's just look at what our internal development cycle is. We can release things internally in smaller chunks and go faster than if we tried to build them in parallel and do 3 or 5 or 10 things all at once and then release them as one big chunk. So in traditional software engineering, this has proven itself out time and again over the last few years. And I've had the privilege to be a part of a number of projects that did that. And the question is, well, if this works for traditional software engineering, can we apply the same principles to our data ecosystem? And what I commonly hear initially when posing these ideas is no, we can't. Data warehouse, data management is different. It's fundamentally different. And, that's true. There's a lot of truth to that. There's a longer cycle in these things from the perspective of there's more steps, but it doesn't necessarily mean that we have to go slower. So we can look at DevOps and we'll use the term data ops, which is a fairly new term in the industry, that they're very similar, but there are just some differences that we'll examine here. So in DevOps, we're going to integrate development and operations tightly, and we'll integrate the ideas and processes to facilitate business objectives with greater speed and synchrony, which sounds great. It's a little bit wordy. Data ops is very similar, right? We're just going to change a couple of words. So I think it's useful to borrow the term data ops so we kind of steal that idea of value that DevOps has sort of been imbued with in the industry. And there are many similarities between them. We want to automate everything. This is one thing we don't always see a ton of in the data space is automation. There's a client we're working with where we're taking some extra time up front to build in all of the rails and automation for continuous delivery. And by doing that, we see immediate benefits from every incremental development that has to occur after that initial rails are laid down. So we automate the builds, the tests, the environment creation, packaging, deployment. And when we do this, these rails are put in place and there's a pipeline that is available to every committer to go through all of this automation sequence and show value at the end of that stream. With these small changes are now able to be rapidly delivered. We have telemetry around the feedback loop, and we have consistent business feedback loop. And what this really means is somebody, maybe they want to change, or maybe there's a feature idea, they talk to a developer, they get through that design component, and the smallest usable version, testable version of that feature is developed. And without having to wait for 10 other features, that individual feature can be pushed through the pipeline and made available shortly after it's been developed. So most of our time is spent in development and running tests for that development, and then the rails to sort of pick everything up and push it through the pipeline. Now, these are not apples and apples, right? So we want to make it clear that there's some important differences between the two. So we do want to bring automation and telemetry into everything, and infrastructure as code, and apply pipeline quality checks. For example, the ability to watch data as it flows through a system and understand when there's been material differences to that data that maybe the code's not expecting. We've built tools that manage for schema drift to understand that certain expected properties aren't available, and then being able to decide from a statistics and ratio standpoint whether or not these should be escalated or that data can still be collected. And so there's just a little more thinking that goes into the testing and instrumentation of these pipelines in order to perform this automation. This is especially important in data ops because data ops has a longer pipeline than traditional software engineering. There's just more steps that need to take place. I hate to trivialize application development, but to some degree, you write your API change and you get that deployed out, and that change is live, and there's a little less ongoing management than there is in something like an ETL pipeline, for instance. There's other aspects in today's modern stack that involve things like machine learning pipelines, which include model building and model training. And when we have to do things like model building and training, that's a whole additional component of that pipeline that just isn't part of a normal app dev cycle. So data has to come in and it has to get pulled together and aggregated and trained into a model that then subsequently gets deployed. And so there's some extra steps depending on what your use case is that need to get applied. There are more complex test data considerations in doing this with data pipelines as opposed to traditional software development. The test data itself becomes a first-class citizen. I think in software dev, sometimes we can kind of do some simple inserts and call it a day, and that supports the test cases that we need. And I think in doing this for data pipelines, there's quite a bit more involved in modeling realistic data scenarios so that our automation and tests can check and balance everything. We also want to include sandbox management as part of our setup because the individual, especially if we're talking about machine learning practitioners, data scientists, those users, their environments are a little bit different than a traditional software engineering environment, and they need to work in a more sandboxed space as part of the kind of front of that whole process. And as they produce something usable, then we might take what they produced and bottle that up and put that into the pipeline. But prior to that, we need to craft the ability to stand up sandbox environments with these test data sets quickly and easily for those practitioners. And then probably much more so than even in traditional app dev, there's more stakeholder feedback that needs to be involved in using these processes for data management, data processing, pushing information through the system. And the reason is that we have stakeholders, not really just in the business side, the product owner, which is often the case in app dev, is we have the product owner and they've carved out what they want, and we need to do those stakeholder demos and show them that we built it correctly. In the data side, we've got business stakeholders that are potentially the product owner similarly, but also sometimes the CFO's office is a recipient of our end results. Operations stakeholders, we have more interaction with operations because often there's many more systems to touch. Analysts and governance as well. So governance, you might have a CISO, auditors, IT ops, you might have a chief data officer that you're working with. So feedback loops in the tech area. Now there's feedback loops throughout, and that's something we want to keep in mind, is that we want this feedback to be occurring from our key business stakeholders, our operations stakeholders, our product owner stakeholders, our analyst stakeholders. These are all different kind of iterative and even nested feedback loops. But one of the most important ones, and this is similar to app dev, is operations to development back to operations. So these teams need to be in very tight lockstep on how the systems need to behave and need to act. And one really important step, both in app dev, data ops, and DevOps, is this idea of incremental improvement projects. So if we have a system that's been built out and there's, let's say there's maybe 50 or 100 different running applications in our system, we always find through telemetry that this or that system is causing a problem. And so we need to be given the capability to establish these incremental improvement cycles. And this is really analogous to solving your technical debt as part of an ongoing piece of business. And so it's important also to work with your business stakeholders, and help them understand the cases where solving technical debt will actually increase your flow and create greater capability for you to deliver projects on time. Other things we can do: identifying the brittle areas, do resiliency testing. Failure scenario dress rehearsals is one that is really hard to coordinate within most organizations, but has a lot of value. So what happens if this component of our system fails? And doing actual dress rehearsals against that to verify that all of that telemetry, testing, and automation that we've implemented is functioning as required. So overall, just circling back on this, if we can decrease cycle times by adding all of this automation and testing into our process, this gives us shorter feedback loops from each of those stakeholders. Those shorter feedback loops net more incremental improvement, which gives us higher velocity, which ultimately gives us shorter time to market. And that's really what we want for our investment in IT. We want to be able to put some dollars into an idea and see that manifest as value back in the CFO's office. And the best way to do this is to shorten the feedback loop and improve our cycle times. So what are the things that prevent data ops from being successful? One of the key ones that we hear about is data silos. One of the organizations we worked with had some compliance concerns that ultimately resulted in these data silos of ownership where there really wasn't much tolerance for crossing the stream, so to speak. So the idea of piping data from 3 or 5 or 6 data silos into a single aggregated store and making that available to a wider group was just not part of the thinking or allowable. So what we did is we created effectively data marts, but functioning as microservices that exposed APIs that were already pre-built to understand the context of the requesting users and what their authentication concerns are, so that a user could not request from that service data that they were not allowed to see. And so that created the ability for different users in the organization to access what data they're allowed to access across all these different systems without having to solve for any harder data aggregation and compliance concerns. So it kept them very aligned with their regulatory considerations, while at the same time enabling appropriately authorized data scientists and machine learning engineers and analysts as well to accomplish their goals. So it's one of the things that happens sometimes is we see these compliance or regulatory concerns, and we react reasonably by saying, well, nobody can see this data, and that's the easiest way to lock it down, but it's the easiest way to prevent your engineering staff from finding ways to add value to your data, to your organization through the use of your data. Another thing that occurs is just people silos, not data silos, but people silos, where people are, they're just on different pages. There's minimal crossovers between the teams. Oftentimes they'll just throw a set of requirements over the wall and say, go implement this. It's really important to get all these teams interacting on a consistent basis, not necessarily, meetings every day, but several meetings a week through the course of a project to share knowledge and learnings as they occur throughout the project. One stat that I looked at, according to Experian Data Quality, 96% of chief data officers believe that business stakeholders are demanding more access to data than ever. 53% said lack of data access was the biggest barrier to decision making. So this is just something we want to figure out how to prevent by applying some of these principles and being able to go kind of to the end of the road there. So we've increased the throughput of being able to make changes in our data ecosystem and manifest those. And then we've added perhaps some APIs to give access to that data in an appropriate and well-regulated manner. So there's a lot of different ways APIs can be used in your ecosystem. They can be used for internal data collection. So we've seen some architectures. I won't go into detail on these right now, but Lambda and Kappa architectures have both been used in order to supply often real-time data streams, which is very useful if we're integrating machine learning models or real-time predictive analytics on behalf of our users and taking into account the latest information. Externalizing data, so the ability to take information that has been produced as a result of all of our analytics efforts and exposing that back to our end users. For example, at the beginning of the presentation, I talked about an organization where we integrated data from 3 different systems in order to produce a report, and that report was actually back to the users of the system, and that was kept fresh in real time. So API access to governed data, trained model results is another example, and we see this a lot in collaborative filtering and things like that. And customer level insights, which is the example that I've given there. Search results can be another feedback loop. So if we have some sort of search in place, understanding how the users are interacting and instrumenting those search results as a feedback loop back to our search algorithm can allow us to grow and get smarter a lot more quickly. There's some additional API enablement possibilities that we can think about. These include some value we can get from API integration platforms, things like Apogee and MuleSoft and API Gateway, and every major vendor's got some version of this. And these integration platforms give us a lot of different capabilities that can really simplify our overall ecosystem. So we can secure and automate data collection more readily. And Joe had spoken on this earlier in his presentation. The ability to automate the information as it gets collected through API. So everything gets collected and exposed via APIs, which dramatically increases your capability to govern and secure your information. They can be used to secure data distribution. We can control data delivery. Most of them add quite a bit of monitoring, security, and telemetry capabilities. So these are things that we don't wind up having to build. So I've been through some scenarios where I tried to build into a system things like how many times can a user call an API, for example. So this ability to constrain API consumption, and you write that once, and then you realize, well, a vendor's already done a better job than I'll ever get to, and it becomes quickly apparent where your core competencies lie and what's worth spending your effort on. There's some value in these platforms in that regard as well. Speeding up the data delivery, integrating data in creative new ways. So if we build up this bus of APIs that have access to the different marks of data in our system, then this becomes really a menu for our data scientists and data modelers to pick and choose and come up with creative ways to analyze that data and come up with new ways to add value to the business as a result of it. They also allow us to rapidly respond to changing conditions. So new regulation requirements come in. If we've centralized this API ecosystem over top of our data ecosystem, then an integration platform gives us a ready way to manage some of those holistic system-wide changes. So to wrap it up, a couple key takeaways. Data ops as a industry term or buzzword is starting to grow up and become its own thing. Born of data ops, but not the same thing. So applying successful DevOps strategies to your data ecosystem. Understanding the critical differences between DevOps and data ops, the fact that they're not the same thing. Data ops really requires more communication between your teams and your stakeholders. There's more feedback, more loops within loops because of the wider array of stakeholders that are part of this. And the overall goal is if we can improve our cycle times through automation and testing and streamlining the pipeline of development and deployment, then we can bring value that much quicker to the business. And lastly, what are the opportunities to leverage APIs and API integration solutions to facilitate this? Things like system interaction and feedback loops, data access governance, and really creativity on the part of the data folks. So that's what I wanted to present on the topic, and thank you very much.
All right, thank you so much, Chris. We're now going to open it up to Q&A. Again, please ask any questions you may have in the questions box on the right panel. So let's start with the Q&A. First question is, do you consider DevOps in this context also contribute to improving the systems of record, meaning analytics uncover the holes in data and systems of record learn to plug them? Joe, I think that was asked during your presentation.
Yeah, I could answer that. So I think there's two separate things that we're talking about. I think the system of record has to do with when you're mastering your data. So when you're mastering your data, you want to find what is the golden source of a piece of information. What the API layer does and the DevOps environment does is it's a mechanism to get to that data. But the API layer would not create that, right? You still need, if you do have a master data management issue, you still need to have a master data management solution. And then the means of disseminating that data can be done through an API layer.
Great. Our next question is, when and how do DevOps collaborate with data scientists and data engineers?
When and how?
I
would say ongoing. Sorry, Joe, were you going to speak there?
Well, here's when I think it's the most important. If you have an environment, if you think of my maturity model, well, if you have an environment where you're creating data through a business application and you are taking that data and putting it into a, like a predictive analytics data science environment like SAS or R or something, and then getting insights out of it, and then taking that insight and doing some kind of business action. Maybe an API DevOps environment might be a little bit premature or over-engineered for what you're trying to do. If you want to say, look, I have these models built, I know where the data is coming from, I need to be able to create insight so that that insight is readily available for the business applications to function differently and better. That's when you want to start introducing your API layer. Once you have the API layer, now that opens up a whole new opportunity for anytime I need any data throughout the enterprise, I can go through an API rather than trying to have direct access to all the different data platforms in your environment, right? But to build an API layer for the sake of building an API layer just purely for users to get data access, I think might be the cart before the horse. I think the API layer and DevOps in general is really for when you're doing application integration between either business applications to business applications or business applications to your analytics platform.
All right. What are some methods that you've used to overcome the people problem to DevOps success?
Yeah, people are harder to program than computers.
That's true.
So this is such a big problem that Caserta actually has a new practice called data literacy. So data literacy comes in and teaches individuals within an organization on what it means to be analytics driven and what has to change from an organization perspective, from a business process engineering perspective, and from a technology perspective. So the three Ps, the people, the process, and the platform. The platform part, the technology part, even though it's everything's easy once you know it. You learn how to use the technology. Now it's not splitting atoms anymore. People, you never know how people are going to react, regardless of how many people you've trained or how many people who have been through a disruption. And what we're doing is probably the most disruptive thing most individuals are going to experience in their career. And it has to be handled very, very delicately. So if you are considering converting into a DevOps environment, the tech is the easy part. The real challenge is the people around the tech and really having a very intentional method of getting those people to come along for the ride and train them, reskill them, or potentially have to replace them, right? But something needs to be done. If we just build a new technology platform and initiate a new way of doing things without having a specific program, a separate swim lane that goes right alongside your project management of the technology implementation, you need to have a people adoption and training implementation as well. Very important.
It's an excellent point, Joe. And that segues us to our last question. How do you even start in a big organization with many existing projects?
Sure. Oh,
Chris,
sorry.
go for it.
I think it's very similar to the answer to the last question. You have to start with the people and understand that that if you're going down this road, there is a bit of a culture shift that's often involved. I'm also a big advocate of show rather than tell. So many times you're better off demonstrating some easy wins rather than trying to convince upfront, assuming that's an option. But there's the top-down approach, which is to say that you get buy-in from whatever it is, engineering management or the CFO's office to adopt some of these new practices or tools, or simply start spending a little bit of time integrating some of the change that you need in your process. And then there's also the bottom-up approach, which is kind of where you start with the show versus tell, where you just start taking into account some of these practices and ideas like the automated testing and automated deployments or schema migration as part of your practices, and you bring the other folks along for the ride by simply demonstrating that this flow can be achieved. As Joe mentioned, it's no longer splitting atoms. There's been so many improvements made with how these capabilities are brought into your organization. Really, whether you're cloud or not, but I think being cloud literate and deployed on the cloud can increase the value that you get out of some of these activities. So I would suggest generally, depending on the organizational friction, starting with the bottom-up approach, really to prove to yourself and to gain some basic skills around, if you're on the technology side, on how you can integrate simple deliberate changes in a system to decrease your cycle time and improve flow, and socialize those changes so that you've got some buy-in from your cohorts. And if you are on the technology leadership side, then it's kind of a different question. I think Joe alluded to that as well. If you're having a hard time pitching these ideas to your technology staff of making these improvements, these incremental changes, and this automation testing, at some point there's the question: do I have the right people, in the staff to support my vision of, hardening my system and increasing our flow?
All right. Thank you so much, Chris. And that's all the time we have for today. Thank you, Joe and Chris, for excellent presentations. Thank you all for attending today. If you have any further questions, please don't hesitate to email me to remy@caserta.com.